Well, thanks, Michelle, for that introduction, and it's great to have the opportunity to present the results of this project here today. It's been nearly 4 years in the making, and it really has delivered a small pot of data gold for us here in South Australia, for those interested in researching South Australia's landscapes. So it really is exciting to finally get to this culmination and be able to present it to what is a continually filling room. So I just want to go back 100 years and think about South Australia. In that time, the place was relatively, and I'll take notice from Dan's talk in the last session, a relatively stable place, relatively uncleared in the sense of plenty of native vegetation around the place in South Australia. And so it was in the last 100 years, we've really started to dramatically alter that balance and started to clear that, most notably in landscape terms. Through the middle decades of the 20th century, we really started to clear native vegetation from South Australia. And so much so that it culminated in a recognition just 27 years ago that a law was needed to make us stop clearing the land of its native plants, the very fabric of the landscape that we live in. So since then, South Australia's collective inhabitants have continued to cause change in the landscape. In order to enhance our lives, to create jobs and growth, prosperity, within the confines of our laws and the capabilities of our industries. We've cleared the landscape significantly up until that Native Vegetation Act in 1991. The question is, how have we been doing since then? Have we been doing that sustainably within both our technology and also our politics? So the question is, how long can we go on imposing that sort of change? And are we succeeding in upholding the intent of that law that we intelligently put in place? What are the impacts from our land use choices and the larger scale changes that we know are happening around us, like climate change? Have we got the right information to think about these issues in terms of the native vegetation in South Australia and the landscape as a whole? The answer we worked out a couple of years ago was, well, no, not really. The report cards that came out in 2014 suggested that we really needed to improve our information in terms of native vegetation. The report cards for extent and connectivity in native vegetation and condition both said, well, we've got some information, but it's not really enough in order to understand the trends in native vegetation. So the quality of that information had been the source of much debate, particularly around age and consistency and the challenges in updating it. So there was this real drive to improve that information, particularly for regional and state level reporting of our vegetation assets. When we did do those report cards previously, it was based on the SA Vegetation Mapping, which was a program of mapping the state's native vegetation, went through the 1990s through to the 2010s. Took a long time to map our very extensive state. There was issues of, it was done sort of area by area, and different people did different interpretations along the way in terms of drawing lines around aerial photographs and interpreting what was there. And you can also see that it's not wall to wall across the entire state, but you can see it did a pretty good job. And that's what we based our first estimates on in terms of the remnancy of native vegetation. So critical for the kinds of reporting and understanding of our landscape dynamics that we've seen in many of the presentations today. Patrick's presentation earlier today as well was talking about fragmentation. And this is the data set that we've been basing that fragmentation and connectivity measures on. So today, as mentioned by the Minister this morning, we're releasing the SA Land Cover data set. This is our response to that problem. We needed better information. We needed something that was through time. And at that point in time, the Geoscience Australia had put together the Data Cube, which is basically a collection of the Landsat satellite archive of their multispectral data collected over the last 25 years. So now we've got a data set that maps different land covers in a consistent way across the whole of South Australia, allowing us to measure changes in the landscape. So this is an open data set for anyone to apply their questions to. And as mentioned in previous conferences, it really was driven by that inability to report at a statewide level that's taken us to this point. There was a lot of data to deal with. There was a lot of, we had to collect the investment together, and we had to get some modelling together, and it really has taken us longer than we thought in order to get this kind of data set out there. This collaborative exercise with Geoscience Australia and the Australian Government and all of our NRM boards has really, as I say, delivered us quite a neat pot of data gold. So if anyone missed it this morning, this is basically what it looks like. It's up on Nature Maps now, which is the department's online mapping tool. You can see that it sits over the top of, there's about 400 or so layers that sit in this application. And you've got the little slidey bar there. We can see change over time happening. So we've created these 6 layers of land cover classes. And when you put them into this kind of application, it does a fantastic job of showing us what's been happening in the landscape. Now, because of the colours we've chosen, forestry really stands out markedly in these particular examples. But as we go into the southeast, you can also see the disappearance of our wetlands there in that sort of teal colour, and also the orange on the right-hand side here, which is the Coonawarra and the vineyards in that area, really taking hold through the late 90s and into the 2010s. So this is freely available for people to go and have a look at and study any area in the state to see. Simply search SA land cover on EnviroData and you will find what you need. So just looking at the land cover classes that there are, we had to boil them down into native, non-native and other. And really the major ones in terms of South Australia's environment, where are we here? Woody native vegetation and non-woody native vegetation, that's our grasses and shrublands, really take up the bulk of the state. But you really can't just map native vegetation when you're looking at the whole of South Australia. You really need to look at these non-native classes as well. And it really gives us that understanding of the relationship between the native parts of our landscapes and the non-native parts, which are very important to obviously our economy and our food generation, etc. So briefly, satellite data inputs, it's largely based on Landsat multispectral information, but there is also some radar, some active remote sensing information in there that adds to the stack. All of the data was pulled out for those 5-year periods, creating the 6 time periods, and then divided up into the seasons. So we've got a phenology aspect to this to really pull apart the native from the exotic plants in the landscape. We had, there's over 800,000 training data or exemplar data points from across the state, also utilising training data in New South Wales, southern New South Wales and Victoria, and we also went and collected some more. Now, it's not stratified consistently across the entire state, but this is the best collection that we could get of robust and dependable data in order to feed the spectral signatures that the model outputs. And just to put it up against really the other national land cover data set that's around, which is the dynamic land cover from Geoscience Australia, which is based from a different satellite platform at 250 metre pixels. The difference with 25 metre pixels, you can really see the resolution. This is southern McLaren Vale here, is completely different. You can really start to see the roadsides. You can start to see water bodies much better defined. There's certainly those sort of water bodies that exist in that part of the country in South Australia. So just running through another little example here of how much of the difference that this data is, how much it's improved for us. These are polygons. This is a part of the southeast. These are polygons from the SA vegetation. And we're really just mapping the large remnant woody chunks that we can see. There are internal lines there that you can see that where we attach different floristic associations to them, but that's kind of the resolution of the data that particular data set that I was showing before. And when you take those internal lines out and we just look for remnant native vegetation, that's the picture that you get. You notice one of we did have another data set, which was our roadside vegetation mapping, which is where people have driven along the roadsides and recorded what vegetation is remnant along those. It's a different format of information, but it certainly helps us in the previous sort of technologies. Now, using this method, as I overlay that, you can see we're starting to pick up in that dark green much better. Just going back one there, all these scattered trees in the paddocks, these remnant trees that are very important for our natural systems and biodiversity to thrive in our agricultural landscapes. But we're starting to really pick those up much more. We're getting those smaller chunks of native vegetation, and particularly along the roadsides you can see there in those scattered trees. So they're coming out much better. So one of the reasons that we wanted to do this was to have a look at regional estimates of native vegetation. So we've previously used that SA Veg data to give us those estimates. Based on this, we've picked up an additional 12,000 square kilometres of previously unmapped native vegetation in SA. And you can see how that bears out in each of these regions, particularly the ones further to the south. So this data allows us to consider changes that we've known about but not really been able to measure, this transition of land between native and production uses. In the low rainfall agricultural regions, the key change was really between native pastures and this woody native or dryland agriculture. In the higher rainfall regions, the conversion of dryland agriculture to plantation and irrigation and irrigated non-woody, so to these more intensive agricultural industries, really came out in the data. So for more information, it's all sitting on EnviroData. You can search land cover on EnviroData and it'll take you to this homepage where it talks about the most likely layers and the continuous layers. And I'm going to run out of time here. These are all of the continuous layers that sit underneath it that were combined and boiled down to those 17 land cover classes. Won't stop on those for too long. Here's an example of one of those. It's basically a probability layer of any of those particular land cover classes beyond the 17. It's being used in things like, to improve some of our modelling, like in the Great Koala Count that Corey Bradshaw has been producing lately. And we're about to see in the next session, next time slot, some applications of those continuous layers to coastal carbon estimations, and also those most likely layers to groundwater models, catchment models, and also topographic mapping it's been used for as well. All in all, this is the beginning and not the end for this land cover data. It's open data. We want everybody to test it, to use it. Come and talk with us about what we've learned about how to use it. There are limitations that exist for obvious reasons, but at first look, it really has great potential for many landscape questions in South Australia. Just want to acknowledge a cast of many that's been involved in this over the last number of years. This list of people have been involved either greatly or smallly over that time. And as I say, it's fantastic now to make this open, and please come and talk to us about how it might be able to fit into your research questions.